PE. We can have multiple path between one PE to another PE. Like in service provider network, I can have topology like this. For two sides only, one PE here and one PE here, and in between I can have multiple provider routers. There can be multiple paths for the redundancy. For redundancy, load sharing, you know between P to P how you will configure BGP. Anyone? How I will advertise customer prefixes through this service provider network? This is P1, P2, another P, provider edge 2. And these all routers are P1, P2, P3, P4, P5. Doesn't matter what is the subnet running between P1 to P1, right, on this link or on this link, doesn't matter. Simply I will create one loopback here on P1, 1.1.1, and one loopback over here, 2.2.2. And through IGP protocol will make reachability between 1.1.1 and 2.2.2. You most commonly used protocol is OSPF here for internal reachability. So you will enable OSPF on all interfaces of P router as well as on the all interfaces of PE router except the interface which is connected with customer. Here service provider can have multiple customer, side 1 and side 2. Again this is same topology. Is there any difference in this topology and in my topology? No, both are exactly same profile. Between P, you have simple design, that's it. And I have only two P router, two customer. Here, this service provider can have other customers also. Here also I can have one side. Here also, right? Or this can be another customer, customer A, B and C, customer 1, 2 and 3. Now service provider need to, first of all, the first requirement in service provider network is separating different customers. How service provider is going to separate all their customers? How they will keep routing table, separate routing table for each customer. We know by default router maintain routing table, that is called global routing table. That is called global routing table. By default routers maintain only one routing table, that is global routing table. And all connected prefixes is installed in global routing table. Routers are going to install all connected network in global routing table. When you will enable any routing protocol, whatever prefixes it is going to learn through routing protocol, it will also install that in global routing table. It is similar like switch. On the switch, by default, you know all ports of switch belongs to single broadcast domain. Why? Because by default all ports of switch belongs to one VLAN. Correct? That's why we called one broadcast domain. So switch maintains single MAC address table. If I have a switch here and I have lots of client machines, all these client machines are in VLAN 1 by default. So switch is going to maintain only one MAC address table, that is global MAC address table. Let's say I have 0/0 or 0/1, 0/2 and F 0/3. Right? Switch is going to maintain single MAC address table and all these interfaces will be part of that multicast. Sorry, that MAC address table. That MAC address table, single MAC address table. If anyone is going to generate broadcast message, it will flood it to all other interfaces. How I can separate the custom, like these endpoints, how I can keep these two endpoint in one box or in one department and this device in another department, how I can separate?
VLANs?
With the help of VLAN. Very good. With the help of VLAN. What is VLAN? VLAN is nothing but logical grouping of end devices, right? Logical grouping of switch port is known as VLAN. So as we have VLAN here on the router, how we can separate the routing table? Now let's suppose here I have created two VLAN, VLAN 10 and VLAN 20. Now switch is going to maintain how many MAC address table? 3 MAC address table. One global MAC address, one MAC address table for VLAN 10, one MAC address table for VLAN 20. One for VLAN 10, one for VLAN 20, and one for the global VLAN 1, the default VLAN. Right? Similarly, routers. By default, all the interfaces of router are part of one routing table, global routing table. But we can create multiple routing table on the router. Means virtually we can divide router. For an example, I have one router R1. This router has two interfaces, F0/0 and 0/1. Can I configure same IP address on both the interface, 0/0 and 0/1? Can I say IP address on 0/0 is 10.1.1/24 and here also 10.1.1/24? Will it give me any error?
Yes.
Will not.
We can't configure.
We can't.
What will be the error? What will be the issue if I will try to configure same IP address on multiple interface?
Duplicate
Overlapping.
IP address.
Overlapping. Issue of overlapping, because Praful, both the interfaces are part of single routing table, same routing table, right? So prefix will overlap in the routing table. We cannot do that. But you can do that with the help of
VRF.
VRF. VRF allow you to divide a routing table of router virtually. Like I can divide it. I can put 0/0 in one VRF. Let's say VRF A, and 0/1 in VRF A and VRF B. Like VLAN, here we have VRF. Now this router is going to maintain three routing table. One global routing table, one routing table for VRF A, one routing table for VRF B. Global routing table for VRF A and routing table for VRF B, right? So now you can configure same IP address on multiple interfaces as well, because when I will configure 10.1.1/24 on F0/0, it will install that in this routing table, right? Here it is going to install that. Prefix is connected 10.1.0/24 on F0/0. When I will configure same IP address on F0/1, so F0/1 is a part of member of VRF B, it is going to make entry over here. So you can see both are installed in different routing table. Route will not overlap. So what is VRF? VRF stands for, let me tell you what is VRF. VRF stands for virtual
routing forwarding.
Virtual router and forwarding, used to divide routing table of router virtually. By default, all the interfaces of router are part of single routing table, that is global routing table, but we can put interfaces in any VRF. After that, here you can see, like in this scenario, what will happen between P and CE, between customer edge and provider edge, you can configure any routing protocol. I had told you that between customer and provider we use generally BGP to avoid redistribution, but here you can also enable OSPF. So on router number 1, you can see you will enable OSPF on G0/2. 0/2 is a part of VRF. So we'll enable OSPF for VRF now. We'll not enable OSPF for global interface. We'll enable OSPF for VRF interface. Routing protocol works on interfaces, not on the router. So if I am running OSPF routing protocol here, then customer is going to advertise LAN prefix to provider edge through OSPF. Through OSPF routing protocol. Here maybe you are using EIGRP. So this customer is going to advertise their prefixes through EIGRP. Both the customers are advertising same IPv4 prefix. But router is maintaining two different routing table, one for VRF A, one for VRF B. So whatever prefixes it is going to learn through OSPF or through customer AC router, it will be injected in this routing table, and prefixes of customer B will be injected in this routing table. In both the routing table, you will have same IPv4 prefix, no problem. Now router has two routing table. Question is how I can advertise this routing table from one P to another P. Praful, the most easiest way is going to have multiple path. Let's say I have multiple link between P, or to make it more simple, here in Paint I can design the diagram. Let's say PE, provider edge 1, provider edge 2. Forget about the provider routers. Provider edge 1, PE1 and PE2. Here are customer is 1, customer A, customer A, side 1, customer B, customer A, side 2. My God. Side 2. Customer B, side 1. Customer B, side 2. See, for both the customer, what service provider can do here, R1, R2, R3, these are customer is router, R4. Okay, here what service provider can do, service provider can put this interface in VRF A, this interface in VRF B, VRF A, VRF B, and they can have two link here between P1 to P2. They can insert this interface also in VRF A, this interface also in VRF A, this interface in VRF B, this interface in VRF B, and just they can enable any routing protocol. Let's say OSPF, right, on all VRF A interfaces and EIGRP on all VRF B interfaces. Now tell me, customer side 1 can talk with side 2 or not? Definitely yes.
Yes, it can. Yes.
Right, but you can see the custom service providers are using two link here, two routing protocol for two customer. If service provider is connecting 100 number of customers here, 100 different customers or multiple 100 sites here are connected on this P router, they need how many links?
Like
100
hundreds of
links.
links, which is not really practically possible. Well,
Right?
it's possible, but it's expensive.
Will not service provider will not do that? Definitely no. Can I do one thing? Can I have single link here between P1 and P2, and through OSPF routing protocol can I advertise both the customer prefixes?
Yes, through different VRFs, yes.
Can I do this? Can I configure here our single link? Let's say, let me close it and let me add one single link. If I have single link here, I have 0/0, 0/0. Yes, Praful. Very simply, you can create sub interface
Sub
f
interfaces,
0 slash
yes.
0 dot 1, f 0 slash 0 dot 2. Here also f 0 slash 0 dot 1, f 0 slash 0 dot 2. And you can enable again OSPF here or EGRP here or same OSPF only. This way also, right, you don't need to connect multiple physical link. With the help of encapsulation protocol, we can do this. Again, we need to configure multiple OSPF or multiple EIGRP session. Can one routing protocol carry both VRF prefixes and we can keep customers separate as well? Answer is yes, but
Yes.
that is possible in BGP only. Even in MP BGP, right? Because what we want between PE to PE, between PE to PE, I want a global session. One global, like this interface. This interface should be the part of global routing table, should not be the part of any VRF. This interface should not be dependent on the customer. I should have one global session, one session of BGP between P1 to P2. Doesn't matter which VRF route I am advertising from one P to another P. Then Praful, how P2 router will understand that this prefix belongs to which VRF? Now let's suppose VRF A, VRF B. Put yourself on mute, guys. VRF A, VRF B. Customer is advertising one subnet, let's say 10.1.1.0/24. Right? Router 1, P1 will receive it, learn it on this interface. This interface is a member of VRF A. It will understand where I need to inject. It will inject the prefix in VRF A routing table. Now when it will advertise to P2 through global session, through BGP session, how P2 will understand that this prefix belongs to VRF A, so it will also advertise to R3 only. It will not advertise to R4. Remember the BGP community. What we'll do? We'll add some communities here in the BGP update message. And community is going to carry the information of VRF. Community is going to carry the information of VRF, BGP community. That's why I told you BGP, through BGP, we can advertise both customer prefixes through one BGP session, and even router 2 can identify, can understand this prefix belongs to which VRF. But we have multiple options. Okay, here in GNS3, if you want, I can show you the most easiest option first, easiest way. After that, I will configure the EVNG lab. For now, let's suppose this is my scenario. To customer, and instead of having router here, you can also have switch, like service provider can use MLS switch also, because on the router, see, PE routers are connecting customers. They need lots of interfaces, yes or no?
Yes.
We know routers has less interfaces as compared to switch, right? So even after PE router, here also you can add one MLS switch, like multi-layer switch, and then I can connect my P router, or your multi-layer switch can also act as a P router. Here by creating sub interfaces, like you can assign one interface of this MLS to one customer, and here you can create SBI. Or this P router can be MLS switch, doesn't matter, configuration is going to be exactly same. There will be no any difference in term of configuration. Let's suppose this is my topology. And here I have one, customer A side 1, customer A side 2, customer B side 2, and customer B side. Clear? Topology is clear to all?
Yes, sir.
We have already discussed this topology. You all already know P router, C router. Now here I can add IPv4 subnet also. Let's say 10.1.1.0/24. Let me perform initial configuration first on the routers. Config T, let me configure R3 first. Interface loopback 1, IP address 10.1.1.255.255.255.0, exit, interface F0/0, no shut, and IP address 13.1.1.3, 255.255.255.0, exit. Let's say I am running OSPF routing protocol or EIGRP routing protocol between P to C. This is my P. P1, P2. You can also add to link, and these are C router. So okay, let me enable EIGRP router, EIGRP ES number 10 and network 0.0.0. This command will enable EIGRP on all interfaces. On customer edge router, customer B, or the same customer another side. First let me put these commands on R3. R3, all the commands are accepted. Here you can verify EIGRP is enabled or all on interfaces or not. So IP EIGRP interfaces, you can see on F0/0 and on loopback 1 EIGRP is enabled. Correct? Now side 2. In side 2 my configuration is going to be on F0/0, on loopback 1 20.1.1, and on F0/0 25.1.1.5. Router EIGRP 10, network 0.0.0, and let me advertise it on R5. I've enabled EIGRP on both customer routers. So IP EIGRP interfaces. Done. EIGRP is enabled on both interfaces. Let me configure customer B also. Loop back over here on router number 4 is going to be 10.1. Same loop back. F0/0 will have IP 14.1.1.4. This customer is, let's say, using EIGRP as number 20, network 0.0.0. Here we have EIGRP 10. Customer A routing protocol is EIGRP 10, and customer B routing protocol is EIGRP as number 20. You can configure any routing protocol. Now I'm using EIGRP only. So okay, let me configure last router R6, IP address 20.1 on loopback 1, and here 26.1.6. Copy and paste on R6. So we have configured the interfaces of customer A, and I have enabled one routing protocol. Now see the provider router configuration R1. On R1, so IP route. This is global routing table. You can see my global routing table is empty. I don't have any VRF, right? Right now router is maintaining single routing table R1 and R2. But as soon as it will create VRF, it will start maintaining routing table for each and every VRF. And here we need to separate the prefixes of customer or customer. Instead of customer A, you can say, let's say this is Dell company. Dell side 1, Dell side 2. And you can imagine this is like HP or IBM side 1 and IBM side 2. So service provider need to separate Dell and IBM prefixes. They will create VRF, right? So that router provider, edge router, is going to maintain one global routing table and one routing table for IBM, one routing table for Dell. One routing table for IBM, one routing table for Dell. See, on router number 1, I am going to create one VRF, IP VRF Dell. Exit IP VRF IBM. Now show IP route. This is the command to check routing table. Then this command is going to give me routing table or global routing table. If you want to check VRF routing table, so IP route VRF and the name of your VRF Dell. Here you can see the Dell VRF routing table is empty and IBM routing table is also empty, because right now I have not assigned any interfaces in VRF. Go to interface F0/0, and in which VRF I will put this interface? I will put this interface in Dell VRF. So IP VRF forwarding Dell. Now 0/0 is a part of Dell VRF. After that, say no shutdown and IP address 13.1.1 255.255.255.0. Do show IP route VRF Dell. You can see in Dell VRF routing table I have one prefix 13.1.1.0/24. The routing information is exactly same. Similarly, interface F1/0 IP VRF forwarding IBM. No shutdown, IP address. If you have already configured the IP address and then you are assigning an interface into a VRF, IP will erase. Again, you have to configure. That's why I'm configuring IP later after assigning interface to VRF. Here IP is going to be 14.1.1, 255.255.255.0. Now, first of all, verify VRF. So IP VRF. I have two VRF, one with name Dell, one with name IBM. You can see here interfaces. In Dell VRF, I have one interface, that is fast Ethernet 0/0. In IBM VRF, I have one interface, that is fast Ethernet 1/0. Forget about route distinguisher now, RD, leave it. So IP route. In global routing table, you can see I don't have any prefix. If I am going to configure F1/1 interface, F1/1, no shutdown, IP address 12.1.1, 255.255.255.0. So this interface is going to be part of global routing table. So IP route, you can see 12. 12 subnet is installed in global routing table. 13 subnet, which is running between R1 and R3, is installed in VRF Dell, and 14 subnet, which is running between R1 and R4, is installed in VRF IBM. Is it clear to all?
Yes, sir.
Yes.
Do same on router number 2 also. On router number 2, config T interface F0/0 IP VRF forwarding Dell. What it's saying, Dell VRF doesn't exist here. So IP VRF Dell, create VRF first, and then IP VRF IBM. Exit interface F0/0 IP VRF forwarding Dell. Exit and interface F1/0 IP VRF forwarding IBM. Sorry. So IP VRF. Here you can see the VRF, but I have not configured the IP addresses. Let me configure IP as well. F0/0 no cert IP address 25.1.2, 255.255.255.0. Exit interface F1/0 no shutdown and IP address 26.1.2.
We are not configuring on VRFs.
Huh?
IP addresses we are configured on global like
No.
interfaces.
So IP route. In global routing table, I don't have any prefix. I'm going to put F1/1 in global routing table. IP address 12.1.1.2, 255.255.255.0. Now you can see, so IP route global routing table. So IP route VRF Dell, we have 25, and so IP VRF IBM, we have 26 subnet in all the VRF. But customers are not advertising any prefixes. Why? Because we have not enabled EAGRP Proful on router number 1. Let me enable EAGRP. Router EAGRP ES number 10. Customer Dell is using EAGRP ES number 10 and network 13.1.1.0. Will it work? Will EAGRP session come up? Do so IP EAGRP interfaces. You can see EAGRP is not enabled on any interfaces. Why? Because this is the configuration of EAGRP4 IPv4 address family for the global, right? If you are going to run network a statement for 12 subnet, it will definitely enable EAGRP on F1/1, right? But 13 network is not, 13 subnet is not running on global interface. It is running on VRF interface. So now we need to configure EAGRP for VRF. Anyone knows how to configure routing protocol for VRF or EAGRP protocol for VRF? Anybody?
No, sir.
No one knows the EIGRP configuration for VRF? Anyone know address family? What is address family?
The address family IPv4, and then you would add route distinguisher, route targets, all of that to achieve this routing.
What is address family? Address family is type of network like IPv4, IPv6. IPv4 is what? One family. In IPv4 we have EIGRP protocol, we have OSPF protocol, we have BGP protocol. Similarly in IPv6 also we can enable OSPF our IPv6 network as well. We can enable BGP our IPv6 network also. So IPv4 is one family, IPv6 is one family. Similarly VRF is also one family. Address family is nothing but types of network family. Address family only tells routing protocols what type of route I am carrying, like in my update message which type of route I have installed, IPv4 route or IPv6 route. Later you are going to learn VPN v4 route as well, right? Or you can say type of technology like IPv4. Instead of sending only IPv4 route, your routing protocol, one routing protocol can send multiple types of route, IPv4 route as well as IPv6 route as well as VPN route, as multicast route, MPLS label, EVPN route. These are different types of routes, and each types of route is handled by a different address family. Earlier your all routing protocol like BGP was only exchanging IPv4 route. Before implementing IPv6, all the routing protocol was only exchanging IPv4 route. But today in IPv6, later you are going to learn EIGRP also, how EIGRP is going to work over IPv6. These are address family. Hope it is clear. IPv4, IPv6, VPN, multicast, these all are address family. Here on router 1, if I want to enable EIGRP for VRF DEL, then this is not the way, right? See, I have removed the network command. Router EIGRP ES number 10, even this ES number doesn't matter. Here address family, under EIGRP I am running address family command. Address family IPv4 unicast for VRF DEL. Now I am under address family. Which address family? VRF DEL. VRF is also one address family. Good. Praful, now you need to run network command. Here you need to define the autonomous system number first. Here you need to define autonomous system number. This autonomous system number which I have configured for global 10 can be anything. Like in EIGRP we know the neighborship parameter. You all know the neighborship parameter, right? ES number must match. So it is not going to check this ES number. It is going to check the ES number which you will define inside the VRF. Address here, if I will exit, address family, VRF DEL and autonomous system. Here you can see I have option to define autonomous. Here my autonomous system should be 10. See, I can configure ES number 100 also. No, router EIGRP ES number 10. Router EAGRP S number 100. Inside EAGRP 100, I can configure two EAGRP for VRF. One for VRF Dell, one for VRF IBM. Address family IPv4 unicast VRF VRF Dell and autonomous system number 10. This autonomous system must match, and then network 13.1.1.0. No auto summary. You can see EAGRP session is up. Do so IP EAGRP neighbor. See, it is not showing any neighbor because I have not checked neighborship for VRF. Do so IP EAGRP neighbor for VRF. Do so IP EAGRP VRF or so IP EAGRP VRF Dell
Sir, just one question.
and neighbor. Yes.
Before, I think you said that autonomous number and VRF number might be the same, no?
No, not VRF number.
Okay.
Autonomous system only.
Yeah, but one which
Autonomous
was
systems
100.
for EAGRP should be same. So where I have configured autonomous system for VRF here. This is not the autonomous system for VRF. This is for global routing
Okay,
table for
okay.
IPv4.
I got it. Okay, thank you.
Right, so this autonomous system doesn't matter. Now you can see EAGRP neighborship is up for Dell VRF, and if I will show you the routing table, so IP route VRF Dell, then in Dell VRF routing table, now I am expecting 10 submit. Here you can see 10.1.1.0 coming through EAGRP routing protocol. In same EAGRP router EAGRP S number 100, address family IPv4 unicast VRF IBM and autonomous system number 20, and here I can advertise 14 network 14.1.0 no auto summary. Now we will have EAGRP neighborship between P and R4 as well, between customer IBM. Let me take you to R4 where it is. R4 router is not configured, so IP interface brief. R3, so IP interface brief 13.3, so IP interface brief R5 25, good. So R6, so IP interface brief 26. Okay, R4 is not configured. Interface loopback 1 IP address 10.1.1 255.255.255.0 exit interface F0/0 no cert and IP address 14.1.4 255.255.255.0 exit router EAGRPS number 20 and network 0.0.0. Now you can see EAGRP is up. Let me take you to R1, and on R1 so IP EAGRP VRF Dell and neighbor. You can see we have neighborship and VRF IBM neighbor. Here also we have neighborship. Now if you will check routing table, so IP route VRF Dell, then you can see in VRF Dell routing table we have 10.1.0/24 coming with EAGRP, and in IBM also you will have same IPv4 prefix 10.1.0/24, and both are separated by service provider. Both the customer routing tables are separated. We'll do same on router number 2 also. Go to R2, and here also let me enable EAGRP router EAGRPS number 10 address family IPv4 unicast VRF Dell autonomous system number 10 and network 25.1.1.0 no auto summary and exit, then address family IPv4 unicast VRF IBM autonomous system number 20 and network 26.1.1.0. Now you can see EAGRP session is up. So IP EAGRP VRF Dell neighbor good and IBM neighbor. Good. So IP route VRF Dell. Good. You can see 20.1.0 and so IP route VRF IBM. Here also you can see 20.1.0. No problem. Both the customers are using same IPv4. Submit. You can advertise any other, like on daughter number 3, if I am going to create any another loopback, that will be also advertised into BGP interface loopback to IP address 10.1.2.1 255.255.255.0. This prefix will be installed in VRF Dell routing table of R1. On R1, if you will check VRF Dell routing table again, here you can see 10.1.2.0 is also installed, but not installed in IBM routing table. You can see. Any question, guys? Still here? All clear? How I have configured? Now, how to advertise exchange prefixes between these two PE router? Right here I have single interface. This can be other part of VRFA. If I will put this interface into the VRFA and I will enable EIGRPS number 20, then side 1 and side 2 of Dell can talk easily. See, on router number 1, by default right now F1/1 is a part of global routing table. So IP route, you can see, so IP route global routing table interface F0/0, and I am going to say IP VRF forwarding Dell, and then again IP address 12.1.1 255.255.255.0, and I will also enable EIGRP on this interface. Neighborship is down. Where I have config IP? Sorry, on F0/0. No. On F1/1 13.1 255.255.255.0. 1 minute. Okay, again neighborship is up. Go to router EIGRPS number 100 and say address family IPv4 unicast VRF Dell, and inside Dell VRF I am going to advertise 12, submit 12.1.0. That's it. Now go to router number 2 and just repeat this process. Interface F1/1. Do so IP VRF. Still F1/1 is not part of Dell VRF. Interface F1/1 IP VRF forwarding Dell. Now IP address is removed. You can see interface F1/1 IPv4 is disabled because this is different address family. Now I have changed the address family over here. Common address family for BGP is IPv4, IPv6, like IPv4 unicast. Let me write here properly. Common address family for BGP, common address family. IPv4 unicast. IPv4 unicast. IPv6 unicast. VPN v4, you will learn this. VPN v6 L2 VPN or IPv4 multicast. These are common BGP address family. So here address family of F1/1 is now changed. Earlier it was IPv4 unicast because we had configured unicast IP address here. So automatically it has configured the address family. By default, all interfaces, on all the interfaces, IPv4 address family is enabled. Even when you are enabling EIGRP, what you learn, you know, in EIGRP, you learn how to configure EIGRP for IPv4 unicast till now. You don't know EIGRP configuration for other address family. Now you are learning address family, enabling EIGRP for VRF address family. So now let me add IP again. IP address 12.1.1 255.255.255.0. Now go to router 2, say IP VRF forwarding del. Again IP address is removed. IP address 12.1.2 255.255.255.0 and enable EIGRP here. Router EIGRP S number 100 address family IPv4 unicast VRF del and then network 12.12.1.1.0. Now I'm expecting EIGRP neighborship between P1 and P2 also. Do ping 12.1.1.
AS number is not defined, right?
Yes,
Like
number is
you
already
gave
Address
defined.
family.
you gave 10 on R2, I think.
That is I think already defined. Just a minute. Ping VRF del and 12.1.1. Routing is there, no issue. So IP EIGRP VRF del neighbor single neighbor. So run section EIGRP address family IPv4 del autonomous system number 10.
See, on global router EIGRP 10 you gave.
IVMS number 20.
Here you didn't put the autonomous system 10, right?
Router EIGRPS number 100. Address family IPv4 unicast VRF autonomous system VRF del autonomous system 10.
You first have to do no.
Do so run section EIGRP. Here I have put it in different ES. ES number 100.
On top.
Okay. No router EIGRP S number 10. Got it. Router EIGRP 100. Address family IPv4 unicast VRF del autonomous system number 10 and network 12.1.1.0. Now I'm expecting EIGRP neighborship.
Other side also true, right?
On router number 1 we already did this. Do so
Here also here.
section EIGRP or router EIGRP yes number 100 is enabled and inside del we are running two command 12 and 13 inside 20 14 and on router number 2 do so run section EIGRP router EIGRP 100 address. What?
Yeah, 25 you have not configured.
Let me configure EIGRP again. Router EIGRP, no router EIGRP 100. Now EIGRP protocol is not running, so IP protocol. Done. Router EIGRP S number 100, address family IPv4, unicast VRF, del and autonomous system number 10, network 0.0.0, no auto summary. Exit address family IPv4 unicast VRF IBM autonomous system number 20 and network 0.0.0. Okay, So IP, EIGRP, VRF, Dell and neighbor. Now we have two neighbor, and if I will check routing table, so IP route EIGRP, so IP route VRF, Dell. Here you can see through EIGRP I am learning 10.1.1.0, 10.1.2.0, both are coming from R1, right? Also learning 20.1.1.0, it is coming from R5 customer, it will advertise to other P1. And now on the customer edge router, like on R3, if you will check routing table, so IP route EIGRP, customer don't know anything about VRF. Customer have no idea about VRF. So customer is learning site to prefix 20.1.1.0. And on router number 5, I am expecting 10.1.1.0. So IP route EIGRP, you can see 10 and 10.1.1.0 and 10.1.2.0. If you will ping from site 1 to site 2, ping 20.101 and source 10.101, ping is working, no problem. But IBM, can IBM site 1 and site 2 talk? Can they talk? No, they cannot talk. Why they cannot talk? Why IBM cannot talk and Dell can talk here? Dell side 1 and 2 are able to talk, but IBM, if I will take you to the IBM side, let's say on router number 4, and so IP route EIGRP, it is not learning any prefix, because Praful, IBM routes are not getting exchanged between PE1 and PE2. I have put this interface, this whole link into VRF Dell. There is no any connectivity between PE1 and PE2 for IBM VRF. Am I right?
Yes.
Right.
So you can add one more link here. One more link here, and now you can put this link into interface F2/0 IPVRF. IPVRF forwarding IBM, no shutdown, and IP address, let's say 21.1.1.1 and router EIGRPS number 100 address family IPv4 unicast VRF IBM autonomous system number 20, and here we are going to run network. You can enable 0.0.0 command, right? So it will enable EIGRP on all the interfaces which are member of IBM VRF. On router number 2 also will do same thing. Config the interface F2/0 IP VRF forwarding IBM, no cert, IP address 21.102.255.255.255.0, router EIGRPS number 100 address family IPv4 unicast. It is already enabled. EIGRP network command 0.0.0 is already enabled. So IP EIGRP VRF IBM and neighbor. Now you can see two neighbor. Now if I will take you to R4, means IBM side router, so IP route EIGRP, you can see it is learning site to prefix. And if I am going to ping traffic, send traffic 20, source 10.1.1, they can communicate. Because we have two transport here between P1 and P2, 1.4 VRF 1.4, 1.4 Dell, 1.4 IBM, 1 VRF for Dell, 1 VRF for IBM. One link for Dell between P1 P2 and one link for IBM between P1 and P2. So simple. Even you can create sub interface F2/0, no IP, address, or simply I can remove this link. F1/0 is deleted, no problem. On this interface I can say no IP address, right, or default command is no default interface F2/0. On router number 2 also config t default interface F2/0. Now again side 1 and side 2 cannot commit. Now what you can do, you can get sub interface F0/2/0.1. Here I can define encapsulation protocol, encapsulation.1q for VLAN 10, IP address 12.1.1, subnet mask 255.255.255.0, exit interface F2/0.2, encapsulation.1q for VLAN 20, and IP address, let's say 21.1.1.1 255.255.255.0, and IP VRF forwarding IBM. Again I have to configure IP address, no problem. And one more thing, interface F2/0.1, encaps IP address, or first VRF del, and then IP address 12.1.1. The IP address is overlapping. Do so IP interface brief. Interface F1/1, no IP address. Interface F2/0.1 and IP 12.1. Good. Go to router number 2 and do same here. Interface F1/1 first. Say no IP address. Interface F2/0.1. Encapsulation protocol should match. Encapsulation.1q VLAN 10 and IP VRF forwarding del, and IP address 12.1.2 255.255.255.0. Exit. You can see again neighborship is up. Interface F2/0.2, encapsulation.1q for VLAN 20, and IP VRF forwarding IBM, and IP address 21.1.2 255.255.255.0. Again here gRP session will come up here, you can see, and again both the customer can talk between side 1 and side 2. Ping is working on R4. In IBM also you can see ping is working. This particular scenario is called VRF Lite. Whatever we have configured, VRF Lite means making communication between multiple sites without having one global session between P2, P1 to P2, between multiple P. You can see again we have two links, two paths between P1 and P2, one for VRF del, one for VRF IBM, right? But you know the disadvantage of this scenario. If 100 customers are there, service provider need to create 100 sub interfaces, right? 100 number of subnet, 100 number of EIGRP session. Database is going to be large, neighbor table is going to be large, routing table is going to be large, CPU utilization of devices can be high. So this is not the practical solution. Will not do this. Earlier we were using it, right? That's why this scenario is called VRF Lite. In my scenario, I am going to configure single, or I can say I am going to configure BGP global session between P1 and P2, and then we'll advertise prefixes of multiple customers, multiple VRF through global BGP session. Through global BGP session. Like here on router number 1, I'm going to say no config T, again interface or default interface f2/0. Do so history, copy it, paste it on router number 2. Again reachability gone. Let me configure this interface in global routing table. Interface f2/0, no shutdown, and IP address 12.1.1.1 255.255.255.0. Now this interface is in global routing table. So IP route, you can see 12 submit is installed in global routing table. Interface f2/0, no shutdown, IP address 12.1.2 255.255.255.0. Do so IP route global routing table. Let me create one loopback here. Interface loopback 1, IP address 2.2.2.2 255.255.255.255, and on router number 1 1.1.1. Interface loopback 1, IP address 1.1.1 255.255.255.255. Let me make reachability through OSPF. IP OSPF 1 area 0, exit interface f0 f2/0, IP OSPF 1 area 0, IP OSPF network point to point. Go to router number 2, interface loopback 1, IP OSPF 1 area 0, and interface f2/0, IP OSPF 1 area 0, and IP OSPF network point to point. Now I'm expecting OSPF neighborship. Here you can see OSPF neighborship is up. I'm expecting reachability between loopbacks. Ping 2.2.2.2, source 1.1.1. Right now let me configure BGP session. Here I have loopback 1.1.1, BGP, iBGP with 2.2.2. Tell me how to enable BGP. Go to R1, router BGP AS number, let's say 500, and neighbor 2.2.2.2, remote AS 500. Anything else? Neighbor 2.2.2.2, update source, loopback 1. Any other command required on R1 for BGP session? Router BGP AS number, sorry, not 100.
Route radius CPF, like connected route radius to it.
No, nothing. Router BGP 500, neighbor 1.1.1, and remote AS 500, neighbor 1.1.1, update source loopback 1. Will BGP session come up? Here you can see BGP session is up, but this BGP session is normal BGP session for IPv4 unicast address family. So IP BGP summary. Here you can see. So IP BGP summary. This is BGP session for IPv4. This BGP session can only exchange IPv4 route. It cannot advertise any other route. Now let me tell you about one another type of route, that is VPN v4 route. Let's suppose here on P1 you can see I have two VRF. P1 I have two VRF. G0/2 is in VRF A, G0/0 is in VRF B, and this interface G0/1 is in global routing table. It is in global routing table. Okay, and between P1 and P2 now I have BGP session. Through this BGP session I want to advertise customer prefixes, VRF prefixes. First of all, we need to make this prefix unique for BGP. So that, see, this is IPv4 route. Here, if I am going to send this IPv4 route to BGP or this IPv4 route to BGP, right? How BGP can understand both are different route? No, both look same, right? Both are exactly same. So first of all, we will make this prefixes, customer prefixes unique. We will make it VPN v4 route. We'll make VPN v4 route. What is VPN v4 route? What is IPv4 route? IPv4 unicast, it is 32 bits. Address represented in dotted decimal, 4 fields. Each field carry value from 0 to 255, right? If I will talk about VPN v4 route, VPN v4 route is 96 bits information. It is 96 bits value. What is 96 bit value? First, IPv4, 32 bits are IPv4 address. And I had told you about, no, okay. (96) means what? 96 means 96 bit means 32 bits IP address plus, if you will subtract 32 from 96, what will be the value? 32 plus
64.
IPv4 plus 64 bits extra information. That 64 is nothing but 32 plus 32. 32 community, BGP community, 2 community value in ratio, right? 10 ratio 10, 10 ratio 10. First 32 bit and last 32 bit. This total prefix, this, if you will combine both IPv4 plus RD, this is called VPN v4 route. Actually, to make IPv4 prefix unique, we are going to add RD value with prefixes, customer prefixes. What service provider will do? Service provider is going to add RD value with customer prefixes. What it will add? RD value. In VRF domain, there is a RD value which is 64 bits value that make VRF route unique for BGP. Like both the customer VRF, both the customer are using same IPv4 subnet 10.1.1.0. Both the customers. How we can identify it? No, we cannot identify it. But if I will add RD value here, then we can make it unique. This is called VPN v4 prefix. RD is route distinguisher. It is used to, route distinguisher is used to
Differentiate.
To distinguish the route.
yes, VRF
Two
route,
different routes, yeah. VRF route
different
with
customer.
additional value, yeah.
Okay.
Are we going to learn route targets as well? RTs?
Yes.
Yeah.
That is not required now. We'll come on that also. Understand first this. Is RD clear? So here, if I am going to say RD value See, this is the prefix for VRF. Del, and this is the prefix for VRF IBM. Good. If I am going to define RD value, RD value for VRF A is, let's say, 10:10, and RD value for VRF B is 20:20. So here it is going to add the RD value 10:10, and here 20:20, and this is called VPN V4 route. This is length of this prefix is 96 bit. Now if I am going to give this to BGP, BGP can differentiate which prefix belongs to which VRF, yes or no? In global BGP table we can differentiate the prefixes of both customer, even they are using same IPv4 subnet, correct? First we have discussed VRF. VRF, virtual router and forwarding. One router can behave like multiple virtual router, can maintain multiple virtual routing table, and we can create multiple VRF, multiple routing table for multiple customer. Each customer get a separate routing table. So if I have two customer, Dell or IBM, or customer A, customer B, both can use same IPv4 subnet, they will not conflict on the provider edge router. But question is, how does service provider carry same IPv4 prefix from different customer? How service provider can carry same IPv4 prefix from different customer across service provider network? By using RD, route distinguisher. Route distinguisher can make customer prefixes or VRF prefixes unique. It is going to make overlapping IP address unique inside the service provider network. And here router number 2 P2 will also have information about this VRF. Whatever prefixes router 2 will learn with RD value, like router 2 will also have RD value in their table with prefixes. Whatever prefix router 2 is going to learn from R5, it will add that RD value. And in the service provider cloud or in the MPLS cloud, later here you will enable MPLS also, otherwise in this scenario ping will not work. Even customer will have route but they cannot talk. So we are going to call it MPLS cloud later, when we'll enable MPLS and we'll understand the packet flow in MPLS. So service provider router can make unique, can make customer prefixes unique globally using RD value. Now see here on router number 1, so IP VRF, RD value is not set. Here in on router number 1 I have two interfaces in Dell VRF, fast Ethernet 0/0 and 1/1. 1/1 is not there interface, or I can say default interface F1/1. On router number 2 also say default interface F1/1. Now again let me take you to R1 and so IP VRF. In VRF you can see route target value is not set. Still this interface is here. Interface F2/0.1, or not like this. Default interface F2/0.1 and .2. Do so history. Now on order number 1, I am expecting only one interface, so IP VRF. Okay, done. In VRF Dell, I have one interface. In IBM, I have one interface. But route distinguisher value is not set, right? Route distinguisher value is not set. We can define this. Config T IP VRF Dell, and then route RD. Here you can define RD value in this ratio. What is ASN, autonomous system, and this NN? Yesterday I had told you this in BGP community. In BGP community, what I had told you? First number and last number. Last number can be your label and first number can be autonomous system. This is different way to use, but you can define any value. Here I said 10:10, so 10:10. And for VRF IBM RD value is going to be 20:20. Now see, so IP VRF. Here you can see the RD value. If I will open the VRF in detail, here you can see route target value is not set, no export VPN route target community, BGP community, no import route map, fine, but somewhere you will find the RD. Here you can see RD value, and here is the RD value for IBM VRF. So IP BGP. Do I have any prefix in BGP? IPv4 route in BGP table? No. Now what I told you, with normal BGP can only carry or exchange IPv4 route. Here we have VPN v4 route. To exchange VPN v4 route, you have to configure MP BGP, which is extension of BGP. 96 bits route is called VPN v4 route, and MP BGP can advertise VPN v4 route, can exchange VPN v4 route. So we have to configure MP BGP session between P1 and P2, because this is normal BGP. Normal BGP share 32 bits prefixes. To exchange 96 bit prefixes, VPN v4 prefixes, we have to configure a special BGP called MP BGP. MP BGP stands for multi-protocol BGP. It's clear with their name only. It is going to carry multiple types of route, multiple types of address family. Multi-protocol BGP. It is BGP only, but it is going to carry multiple protocol, multiple address family. And one more thing. Okay, first of all, let me set up MP BGP session between P1 and P2. How to set up MP BGP? Anyone knows the configuration? Router BGPS number 500. You know, by default one command is running, that is neighbor 2.2.2.2 activate. You know, this command is enable for whom? For which type of prefixes? For IPv4, for IPv4 unicast. If I am going to say no to this, because I don't need normal BGP between P1 and P2, I can remove this command. No neighbor 2.2.2 activate, right? Now you can see BGP is enabled, but you don't have neighborship, normal neighborship. Even that is not required. If you want, you can activate. If you are advertising some normal IPv4 route, you can keep IPv4 BGP session also up, and you can configure address family as well, like BGP session for address family. Now again you can see BGP session is up. But for other address family, this activate command is disabled by default. By default, it is only enabled for IPv4. Now I am going to activate the neighbor for VPN v4. So address family VPN v4, and see first what I said, actually this is my configuration of BGP by default. Router BGP number 500, and this command is hidden, address family IPv4 unicast, then neighbor 2.2.2 activate. This command is hidden, I have not enabled, but it is automatically enabled behind the scene. It is only enabled by default for IPv4 unicast, not for other address family. So similarly I will activate the neighbor for other address family also. What are the address family? Here are the address family. I am going to enable activate neighbor for VPN v4 address family. So address family VPN v4, address family VPN v4, and neighbor 2.2.2.2 activate. So IP BGP summary. So IP BGP so IP BGP VRF. Sorry, I'm saying VPN v4 all and summary. Here you can see neighborship 2.2.2. On router number 2 also you have to activate the neighbor router BGP number 500 and address family VPN v4 neighbor 1.1.1 activate. Now your neighborship will come up for VPN v4. Here you can run command show IP BGP, show IP BGP VPN v4 all summary. Here you can see neighborship is up and receive route is 0. This is what? This is MP BGP session between 1.1.1 and 2.2.2. Now you have both session, normal iBGP as well as BGP for VPN v4 address family. If you want to disable normal IPv4 BGP, you can disable that. Config T router BGP 500 address family IPv4 unicast and neighbor 2.2.2 activate. I can remove this command. No. What will happen? So IP BGP summary. So IP BGP summary. Now you can see I don't have BGP session, but so IP BGP VPN v4 all and summary. We still have BGP session for VPN v4 address family, correct? Now I don't have BGP session for IPv4 address family. I have BGP session for VPN v4 address family. Yes or no? Any question?
Yes. No question.
Now this BGP can advertise VPN v4 route. Great. How it will advertise, Praful? It will advertise if you are going to advertise any prefix here on router number 1. So IP route VRF del. In VRF del routing table, you can see router 1 is learning some protocol through EIGRP, right? But it will be not installed in BGP by default. If I will redistribute EIGRP into BGP, then it will inject these prefixes in BGP table, correct? Or you can use network command, or you can use network command. So go to BGP router BGP number 500 and address family IPv4 unicast VRF del and redistribute EIGRP ES number 10. Redistribute EIGRP ES number 10 and do so IP BGP. This is normal BGP. Do so IP BGP VPN v4 all. Here you can see all the prefixes are injected in the BGP table. All the prefixes are injected in the BGP table. If I will open this prefix in detail, so IP BGP VPN v4 all. Here you can see my BGP table, and if I am going to open any prefix in detail 10.1.0, then see. This is what, guys? This is your VPN v4 route. You can see RD value and then IPv4 route. MPBGP can advertise it. Router 1 will advertise it to their neighbor. To whom? To R2. So IPBGP VPN v4 all. But here on router number 2 we don't have route. On router number 1 you can check so IPBGP VPN v4 neighbor all neighbor 2.2.2.2 advertise route. R1 is advertising these all prefixes, but why I'm not able to find anything on R2? How router number 2 will understand which prefixes should be imported in which VRF? Which prefixes should be imported in which VRF? On router number 2, in BGP table I don't have any prefix because I have not redistributed EAGRP into BGP. Here also I am going to redistribute. Router BGPS number 500, address family IPv4, unicast, VRF, Dell. What happened?
Doesn't
RD
have
not,
a RD configured.
not configured on this R2. Yeah.
IP VRF Dell RD 10 ratio 10, and here you can configure other RD value as well. That is not the issue. 10 ratio 10, and so IP VRF IBM RD 20 ratio 20. This is just unique identity. You can define any value to make prefixes unique. Now a router BGP AS number 500, address family IPv4, unicast, VRF, Dell, and redistribute EAGRPS number 10. See, I have redistributed EAGRPS number 10 into BGP for VRF Dell. Now, so IP BGP VPN v4 all. Here also you can see the BGP table. 20 prefix is injected, but R2 is advertising it to R1 to P1, but P1 don't know in which VRF I should import it. That's why here we have one more concept of RT, route target. Route target is used to import and export VRF or import and export routes in VRF. How? See here what we can do. I can tell to R1, hey R1, when you are going to advertise VRF A route, right, to your BGP neighbor, then export one BGP community which is RT 100 ratio 100. Now you know what R1 will do. R1 will include this community in their BGP update message, and I can tell to R2, hey R2, whenever you will see RT value route target 100 ratio 100 this BGP community, then import that prefixes in VRF A. Means I will say import RT 100 ratio 100. If you are going to import 100 ratio 100 in VRF IBM, that is going to be route leaking. That is going to be my route leaking, because R1 is exporting 100 ratio 100 for VRF A and R2 is importing 100 ratio 100 for IBM, for VRF IBM. So this route can be injected, can be advertised to R6, or can be installed in VRF B routing or VRF IBM routing table. Getting my point, guys? See, let me show you with practical. Here on router number 1, you can see if I'm going to open my VRF, so IP VRF. Okay, this is clear. So IP BGP VPN v4. This is my global BGP. In BGP, I have some prefixes. If I am going to open prefix in detail 10.1.0, here you can see VPN v4 prefix. To advertise VPN v4 prefix, you can see these are what? These are what? BGP attributes.
Attributes.
These are BGP attributes. Do I have route target attribute here? No. So IP VRF detail. If you will check VRF in detail, you can see for Dell VRF Dell, we are not exporting any route target, as well as we are not importing any route target. For IBM VRF also, we are not exporting or importing any route target value. Based on route target only, you are going to export VRF route as well as import VRF route. Let me configure it. You will understand better in better way. IP VRF Dell and say route target 100 ratio 100 export route target, and here you can define export, import, or both. I'm saying export 100 ratio 100. Now R1 is going to export a route target value in the BGP community. So IP BGP VPN v4 all and 10.1.1.0. With 10.1.1.0, is there any new attribute? In the community? Not yet. Go to R2 and check BGP table. Router 2 is still not receiving 10.1.1.0. Now on router number 2, I am going to say import that route target value IP VRF Dell and route target import 100 ratio 100. Now if R2 is learning or receiving any VPN v4 route with target value 100 ratio 100, it will import that in which VRF? In Dell VRF. So IP BGP VPN v4 all. Now you can see 10.1.1.0 is installed in BGP table. It is installed in BGP table. If you will open here it in detail 10.1.1.0, VPN v4 route, one available path, best path, attribute, in external community, see route target value. What route target value is coming? 100 ratio 100. And router 2 is importing this route target value in which VRF? In VRF Dell. So IP route VRF Dell. In Dell VRF routing table, you can see 10.1.1.0 and 10.1.2.0 is installed. Will provider edge advertise this to customer side 2 to router number 5? Will R2 advertise to R5? Go to R5 and check. So IP route, no, not coming. Why? Because here I am running which protocol? EIGRP. Here I am running which routing protocol between P to P? BGP. So prefixes are coming through BGP. Now you have to redistribute BGP into EIGRP. That's why to avoid this redistribution, you can enable BGP between customer edge and provider edge, so that you don't need to perform redistribution. Otherwise, on router number 2, as soon as I will say router EIGRP yes number 100 address family IPv4 unicast VRF Dell, and here if I am going to say redistribute BGP yes number 500, and now go to router number 5 and check routing table. Nope. What happened? Now R2 should advertise redistribute BGP 500. Do so run section EIGRP. Router EIGRP 100 address family IP with autonomous 10 network 0.0.0 and redistribute BGP 500. That's correct. Why R5 is not learning side one prefix? So IP EIGRP topology. What is the issue? Let me see. There is some mistake in configuration. Redistribute said do so run section router EIGRP. Do so IP BGP VPN v4 all 10.1.1.0 coming with next hop 1.1.1 do so IP route VRF Dell. Why it is installed in routing table?
So for that address family should be VPN v4, right?
Where? In EIGRP. In EIGRP, we are redistributing BGP only, not defining address family. Okay, sorry. In EIGRP, how we redistribute route? It was. Is it the way to advertise route in EIGRP? No. Router BGP, router EIGRP S number 100, address family IPv4, unicast VRF Dell, and say no to this. No. If you will redistribute any routing protocol in EIGRP like this, it will not redistribute. Redistribute BGP S number 5 and metric. You have to define K values, correct? Bandwidth, delay, load, and MTU. Now on router number 5, I can check. Now you can see all the prefixes are advertised, right? So who is advertising? Provider is, and it has updated the next hop as well. That's why it is reachable. But on R3, you will not have site to prefix so IP.EIGRP. No. Reason? We have not configured, we have not export any route target value from R2 to R1. So similarly for Dell VRF, what you are going to do here, you are going to export 100 SU100 and on R1 you will import. So better to configure both import and export together. See here on router number 1, instead of configuring export and import IP VRF Dell and do so run section VRF. In del VRF, I said route target export. I'm going to say no to this. No. And then route target both. If you will not define anything, it is going to say use both. Means import and export. It will export 100 SEO 100 as well as it will import 100 SEO 100. Similarly, on router number 2, IP VRF del and route target 100 SEO 100 import as well as export. Now again on router number 5, so IP route so IP BGP VPN v4 all R1 is not advertising prefixes again with any mistake. So IP VRF, so IP VRF detail. Here you can see what we are saying for del VRF. Export route target 100 SEO 100 and import 100 SEO 100 on R1. So IP VRF detail import 100 SEO 100 and export 100 SEO 100. That is fine. So IP BGP VPN v4 all. Okay, it was taking some time. Now on R5, okay, routes are installed. Go to R3 and here also you should have route now. No, because on router number 1 we need to redistribute BGP into EIGRP. On R1 also we have to say config T router EIGRP S number 100 address family IPv4 unicast VRF del and redistribute BGP S number 500 and metric. Go to R3 now and check routing table. You can say 20.1.0 is coming. Similarly, I can make reachability for IBM also. Go to R1 and in the same EIGRP, I'm going to say address family IPv4 VRF IBM and redistribute EIGRP S number, sorry, redistribute BGP S number 500 and metric. Done. Do so history and I will do same thing on router 2 also. Router BGP, sorry, router EIGRP 100 address family del redistribute BGP. It is already redistributed and I need to run this command redistribute BGP 500 in IBM VRF on router number 2. Router EIGRP 100 address family IPv4 VRF IBM and redistribute BGP 500 with this metric. Now go to R4 means IBM side and so IP route EIGRP. Maybe it will take some time or on router number 1. So IP BGP VPN v4 all. No, VRF route is VRF IBM route is not injected in the BGP table here. Reason, I think redistribution of EIGRP into BGP. Router BGPS number 500 address family IPv4 unicast VRF IBM and redistribute EIGRPS number 20. Do so history. Copy and paste on R2 also. That's all. Now on router number 4 or on router number 1, first let me check table. So IP route VRF IBM, it is learning 10.1.0, good. So IP BGP VPN v4 all. Here now you can see 20.1.1.0 is also installed in BGP. it will advertise to R2. So IP BGP VPN v4 all 20.1.0 is coming from R1 and it will advertise to R6 through EIGRP. So IP route EIGRP. Route is not there on router number 4. So IP route EIGRP not there. Is redistribution done?
On R6 is
we
Monday.
need to export and
We then configure route target value. So IP
yeah, for
BGP
IBM.
20.1.0. Yes, here you can see for 20.1.1.0. So IP VRF detail. For IBM VRF, we are not exporting route target value. So IP VRF, IBM and route target both import export 200 ratio 200, and on router number 2 I will say import this route target value IBM route target both 200 ratio 200, and now go to router number 4 and check routing table. Just wait for some time, you will have route. On router number 2, so IP route VRF IBM. It has installed 20.1. Yes, it has installed 20.1.0. 20.1.2.0 is not there. 20.1.2.0. It should come through EIGRP 20. So IP EIGRP VRF IBM and neighbor. Yes, neighborship is up. So IP EIGRP topology. You have to find the command always VRF IBM and then topology 20.1.1.0. Why 2.0 is not coming from R4? So IP EIGRP interfaces. EIGRP is enabled on both interface. So IP EIGRP topology 20.1.1.0 and 10.1.1.0 both the routes. So IP route EIGRP. Now you can see the routing table of R4. I am on IBM side 1, and if I will take you to IBM side 2 R6, then so IP route EIGRP 10. It is learning 10.1.1.0 through EIGRP. If I will ping from IBM side 1 to side 2, ping 20.1.1 and source 10.1. Ping is not working, but route is present in the routing table on R3. So IP route EIGRP. Yes, side 2 prefix is there. And on R5 side 2, so IP route EIGRP. Side 1 prefix is there. If I'm going to ping 20.1.1 and source 10.1.1, ping is not working. Now this is your question, right? I will ask you tomorrow why ping is not working. You need to troubleshoot.
For VRF, we need to mention that VRF, right?
Customer don't know anything about VRF, sir. VRF is for service provider only. Is customer going to send traffic in VRF? No. User are going to access the application, right, which is hosted in site 2. They don't know anything about VRF. Do I have any VRF on R3? So IP VRF. Do I have VRF? No, nothing.
No.
So route is there, but ping is not working. Do you want to check packet flow? If I am going to ping 20.1 from 10.1, source IP 10.1, destination IP 20.1, router 3 is going to compare destination with routing table, so IP route 20.1.1. Next of IP address is 13.1, means it will send traffic to R1. R1 will receive traffic on which interface? On fast ethernet 0/0. Fast ethernet 0/0 is a member of VRF Dell. So router 1 is going to compare destination with their routing table. Which routing table? Dell VRF routing table. So IP route VRF Dell, and here you can see destination IP 20.1 is matching 20.1.1. Destination match in this submit. Next hop is 2.2.2. router 1 is again going to look routing table, so IP route 2.2.2.2 to send traffic. Next hop IP address is 12.2. R1 will send traffic to 12.2. R2 will compare destination with routing table. Again, how R2 will compare destination with routing table? Now tell me. R1 is receiving traffic on which interface? On F1's 2/0. So router is going to compare it in global routing table. So IP route 20.1.1.0. What it's saying? Network not in table. Router 2 should check VRF Dell routing table, then only it will find route for destination, correct?
Correct.
It is receiving on this interface, which is part of global routing table. That's why ping is not working, because this is user traffic. So let me do one thing for you. Interface F2/0. Interface F2/0. And now you can see ping is working. Customer A, like customer Dell, is able to talk with each other, side 1 and side 2. Similarly, IBM can also talk. You can see ping is working. So what happened after enabling MPLS is not your concern now. Leave it. We'll see that in MPLS lecture. That's all for today. If anyone have question, please ask. Otherwise, practice this lab. Tomorrow again we'll configure same over here. Same thing in first hour. Configuration is going to be exactly same, so that you can revise. If you all will configure this scenario and everything is going to work well, then maybe I will not configure this scenario and I will move further. It depends on you guys. Yes.
Can you share both the images, please?
Images? Which images?
Yeah, those, like the paint and the other topology you had.
Take a screenshot.
This yeah, this one I took. The other one. Yeah, this one. Okay, I'll just take a screenshot. One second.
Take a screenshot and send it in group. Here it is.
Sir, can you hear me?
Yes, I can.
Sir, I've been in and out for this whole week due to some reasons, but I just joined this call just like 5 minutes ago. Just give me one, just like what's the topic that was we discussed today? Pretty please.
VRF and MPBGP.
VRF and MPBGP. Okay. And will you please share yesterday's recording and today's also?
Yes,
Pretty please.
definitely.
Okay, sir. Thank you.
Welcome. I'm going to share both recording today after class. Yesterday
Yes, sir.
recording and today recording.
Yes, sir. Thank you.
Which day was the yesterday?
Day 7, I think.
Day 7.
Day 7.
BGP day
And
6.
today is day 8.
Yes.
I think this was the recording.
Then R2.
Yes.
Yeah.
Police
That
stop and
was 4 was yesterday. Today is 5.
yesterday was day 7, sorry.
7. Day
Day
7,
7,
sir.
yeah. Today is day 8, yeah.
And today is day. Day
I
8,
think your recording is still going on.
no.
You might want to
I
stop
think
it.
day 8 is already BGP, day 5, 6, day 7, day 8. Yeah, sorry. Oh my